talk for a couple of minutes right here, and you can keep working on that, about NAT, Network Address Translation. We've kind of talked about that before. It's the thing that kept us in business for IPv4 for a lot of years. But this is the how to do it. So we want to use NAT in order to extend the number of IP addresses that we have to protect the IP addressing scheme of our internal network and to allow us to buy fewer IP addresses. Then they talk about the list of things that can be helpful when you need to connect to the internet and your host don't have globally unique IP addresses. That means routable IP addresses, ones that you bought. When you change to a new ISP and requires you to renumber your network, instead of doing that, you can use NAT. When you merge two intranets and they use duplicate addresses. The NAT advantages is it conserves IP addresses, remedies the address overlap, increases the flexibility when connecting to the internet, and eliminates address renumbering as the network evolves. Can cause translation delays, loss of end-to-end traceability, and some applications, particularly security applications, don't work in NAT. They see it as a man-in-the-middle attack. When do we want to configure NAT? What we typically do with it is in our private IP addresses, in our protected network, we use private IP addresses, which are the 192, 168, the 10s, and the 172s. Going up to here, we have to have public addresses going out, but what NAT allows us to do is to not buy the same number of addresses, buy a lesser number of addresses than we have workstations. If we use a straight NAT, it's a one-to-one public to private IP address assignment. We can also use this thing called overload, which uses PAT, or port address translation. It uses a single or fewer IP addresses and uses ports instead of unique IP addresses. That's probably that's what I use. It's probably what you use at home, is you get a public address and you may have more than one computer on that address. What the router that we have uses is our public address and then some port number, some random port number to create a socket. When it comes back, it has a mapping that the public IP address and that port number goes to a private IP address and its port number, because it's going to have a port number associated with also. So it's usually on a border router, usually on the outgoing router, the one that is at the internet border itself. The different types of NAT: static NAT, which is a one-to-one. You would use static NAT for something like if we had our firewall or our router here and we had maybe a web server, and out here is the public, and for some reason we put it in here on a private IP address. I've done this before. We would NAT, static NAT, a public IP address to our private IP address so that it would always get there. So if you want something to stay the same in NAT, you use a static. It's a one-to-one mapping between the local addresses are going to be private addresses, global addresses, public addresses, routable addresses. Dynamic NAT is what most people use. Dynamic NAT uses a pool of addresses, and we have our addresses in here, and as a workstation needs an address, a pool comes out and NATs the private to public using that one. The next one uses the next one, the next one, the next one. When they get done with the access to the internet, it gives back the address into the pool so that the next user can use it. If you run out of addresses, you can use this overload command, which we'll see in a minute, at the end of the NAT command, which will then go, after you run out of addresses, go into port address translation, which means that you really don't have to buy a whole lot of addresses. The ability to map unregistered to those. Overloading, we talked about. The most popular type of NAT configuration, it uses, and the example I'm going to do, use a single IP address, and then it will map ports. Because remember, when you get an IP address and a port, we have a socket, and that's what it's going to come back to, is to that socket. And the mapping will send it to the right direction. Again, you may or may not do that at home if you do port forwarding, those kinds of things. This right here says the most difficult part of using NAT is the Cisco terms. I agree. I've got a picture here to hopefully make a little sense. The inside local address is the IP address of the computer on your private network. So it's the private network. The inside global is the public address, public registered address that the outside network sees as the IP address of your local host. So it's going to be the one it's going to be NATed to. The outside local is the local IP address from the private network, which your local host sees as the IP address, and then the outside global is the public registered address of the remote host. And these terms just drive me batty. This one shows inside local, which is going to be this guy. The inside global is the source used after translation. So it's the NATed address. The outside global is the outside destination or host. It's the real internet address. And then the outside local is the address on the internet that you're going to. Is the address which the source host is known on the internet. Another picture here, and it says local and global refer to the location of the packet. Inside and outside is the device. So the inside is where the device is. So this is going to be inside addresses and then outside addresses. Basic NAT destination, what this thing is showing is that we're NATing addresses one-to-one. And this can be either static or if we had enough addresses in the pool, it would go to these things. What the whole purpose of NAT is to use a private IP address inside, and after it goes through the router, it gets a public IP address so that it can be routed on the internet. It also conserves IP addresses because you don't really need all of them, especially when we use overload or PAT, port address translation. What PAT does is uses the overload, and this shows that 1.3 goes to 2.1 with a 1024. Each of these, you'll notice, has a different port address, but the same IP address. So in the NAT table, this one is NATed here so that when the information comes back, it gets sent back to this private IP address. So PAT, port address translation, is the thing that really saves us IP addresses. It's the thing that saves you and me IP addresses because we only need one at our house. So the first thing that we need to do is to tell the interfaces whether they're inside or the outside. And the private's going to be, and you go to the interface and type the IP NAT inside or IP NAT outside when we do these things. And then when this one says IP NAT inside source static 10.1.1.1 what this is going to do is NAT from inside to outside. It's going to NAT 10.1.1 to 170.46.2.2. A pool is probably to me the easier way to use it. The first command is IPNAT pool. You name the pool. He names his Todd. You can name it my pool or whatever else. Cisco will probably tell you what to name it. And then this is the starting and the ending IP addresses of the pool. And then the net mask 255.0.0. And then we tell it IPNAT inside. IPNAT inside. We're going to NAT from inside. Source list 1. We'll get to source list 1 here in just a second. Pool Todd. The pool we got because we already created the Todd. The source list goes with the access control list down here. The access list, permit 10.1.1. This is the permit is the network, a private network that's being natted. And then we got the wildcard mask again, everybody's favorite. So it's going to allow that entire subnet to be natted from the 10.1 addresses to these 170, 168 addresses. And they'll be done automatically through the dynamic. And overloading, and when you do overloading, it's a matter of doing this IPNAT inside, all that other stuff, and just put the overload command at the end of the statement. And that automatically, once you run out of addresses, puts it into PAT, port address translation. It'll use NAT until you run out network address. Network address is actually 1-to-1. PAT is 1-to-many addresses. The NAT example here, RFC 1918 addresses, private IP addresses, the 192.168, the 10 addresses, and the 172.16 addresses. So in this one, he does his, and you notice that what he doesn't show here is the actual configuration of the internet, which is IPNAT inside and IPNAT outside. The inside, this would be the inside address. This would be the outside the inside interface and the outside interface. IPNAT pool, the access list, and then IPNAT inside to outside. To show these things, show IPNAT translations, and then if you want to see what's going on, debug NAT. Show IPNAT translations will show what's actually been natted. What I want to do again is to try a demo. If I can get all this stuff closed and get my packet tracer open here. I think this is the wrong one. That's the one we just did, isn't it? This one. This is the one that's similar to the ones on page 553 if you want to go there with this. The only thing, it has an extra router. All I'm going to do is go to this Fast Ethernet 01 with a NAT. The way this thing's set up, this over here on the far left is the 192.168.1.1 network. In between the routers is the 192.168.2 network, and I've got the 3 network over here, which we're not going to use. Page 553. So what I want to do, and you see I've tried it out, so I think it's going to work, is we will ping, I'll start at the beginning, 192.168.1.1, which is going to be its default gateway. 1.1 will be Fast Ethernet 01, which is its default gateway. 2.1 is Fast Ethernet 00 on the other side of that router. It should still work. 2.1. 2.2 is Fast Ethernet 00 on router 1. It should not work because it doesn't have a route back. So it's not working. Okay? What I want to do is on this router, router 0, create a NAT configuration, and I'm going to use his, which is going to be a dynamic NAT a NAT configuration, which is actually going to wind up being strictly an overload, because I'm going to go use one address. We could use multiple addresses, and when you get into want to play with labs, use some multiple addresses on those things. Oh, come on, all I want to do is move you. Okay, so in this thing, and if you look at his, we'll go to enable mode, and then we'll config T, do show run. I want to show that these interfaces don't have the commands that they need on them, and he doesn't show it in here. That I wanted to show that. What we have here, fast Ethernet 01, probably a good way to do it, although it's probably what I wouldn't have done. One looks like an I, so that can be the inside interface. Fast Ethernet 0/0, the 0 looks like an O for the outside interface. So what we need to do first, interface Fast Ethernet 0/1 is set IP NAT, and this is inside. We need to tell it that we're going to NAT. He kind of says that, and then when he gets into the demos, he kind of skips over that. But you have to have those commands or it won't work. And now we need to go to interface fast Ethernet 0/0 and IP NAT outside. And I think I got those right. Now then, we can go into the configuration. What the first thing we'll do is set the NAT pool. NAT pool. I'm going to call it my pool. I did? Well, we'll do a poll then, huh? Thank you. Thank you. My pool. And just like he did, he only uses the start address 192.168, and I'm going to use 1.1.1.1 because that's the network that I'm actually using. And I'm going to use the ending address. We'll use my poll instead of my pool, huh? 192.168.1.1. And in this case, when I get down to actually doing it, I'm going to have to use overload because I only got one address and I'm actually using that address. That is the address of the NIC on the outside. I should use 2.1. Otherwise, it won't go anywhere because that is the address on the outside NIC.
Every time I try to do what you just did, I have to erase everything.
Use the front and back arrow keys.
Yeah.
Just use the arrow keys. And if you want to go to the beginning of the line, use Control A. The end of the line, Control E.
Okay.
There are some things that move around. And I think Control B is back one character. So, and then we need to tell it net mask. And this one actually is a mask, a network mask, a net mask. So it's going to be 255.255.255.0 because that is the mask on that network. And I maybe didn't have any. Access list 1. And what we're going to do is permit 192.168.1.0, that entire network, because that's the guys that we're going to NAT is that network. So we're going to permit that network. What we're doing is saying we're going to permit those guys to get new addresses. And then we're going to, again, use our famous wildcard mask, 0.0.0.255, right? And now we're going to tell it to IP. And if we look at these things, IP, again, we have NAT, I think. Yeah, IP NAT, space, and then the question mark. Inside, outside pool, what we're going to do is IPNAT. We're going to IPNAT inside, because we can, if we natted from outside, we'd be netting from outside, from the internet side to our private network. If we do this IPNAT inside, we're going to net from the inside to the internet. IPNAT inside. Yeah, let's go back and look at what the question mark is. Source, and there's the source address translation, and if we'll look at it, question mark again. The list is the access control list. So it's going to be list 1, because I did use list 1, didn't I? Pool, and I did my poll, right? Didn't I spell it wrong there too? And then we're going to use overload. And overload says that when I run out of IP addresses, which I already have, to use ports. And now, let's go back and see if any of this works. We know the other ones should work. Let's see if this one works now. So now then I can get to the 2.2 because it actually has an address that's on that network. We've given that. What were the commands to show all of that NAT stuff? Do you remember them? I don't. Show IP NAT translations, and we have 192.168.1.2, which is this machine that we're using. Is the outside local is 192.168.2.2 25. This thing is using the ICMP, what we used, these things, and each one of them got a different port number, but it's using the same IP address. The 1.2 translates to the 2.2, which was one that I used, but with port numbers so that it now works back and forth. You can use statics. I think the dynamics with the pool is probably the easiest thing to use. I would always use the overload command, I think. I know that one's fast, but hopefully it makes some sense. What we're doing with NAT is taking a private address and translating it to a public address. I know that I did private to private here, but if we had actually bought an IP address, it would translate to that. That PAT is what your home router does, because you get one public IP address from your ISP. It creates a NAT table, a port address translation table for all the computers on your network, and goes to the internet that way using that public IP address. One of the things it does is your internal addressing scheme isn't revealed that way. And that's what a lot of people like. IPv6 has no NAT. There's enough addresses that everything gets an address. Questions?